Welcome everyone, I'm Adam. In this problem, we're going to find the standard form of the equation of the ellipse with the given characteristics, where we have that the center is at the point 1, 4, we have the relationship that A is equal to 2 times C, and our vertices are at the point 1, 0 and 1, 8. Now, we're not going to sketch the graph of the equation, but we are going to sketch some of these things just to kind of visualize what we have to help us see what sort of form the standard form of the equation will be in. So, first taking a look, well, we have the center point at 1, 4. So right here, x equals positive 1 and 4 is our center point. And we have that our two vertices are at the points 1, 0. So one vertice down here at 1, 0, and also x equals 1, y equals 8. So another vertice up here at the point 1, 8. Now what can we get from this? Well, first off, we see that our vertices are going vertically, so that tells us our major axis is vertical. So that tells us the form of our ellipse is going to look like x minus h squared over b squared plus quantity y minus k squared over a squared, and that's equal to 1. Okay? Now, the a, again, is the distance along the major axis from the center out to the vertices. So this a we can get right away just by looking at the distance from our center out to our vertices, which we see as a is equal to 4. So we have one of the numbers. So we have a, all we need to do is find b, plug it in, knowing h and k from our center, then we have the standard form of our ellipse. So how are we going to find b? Well, we have this relationship between c, b, and a, where we know that, namely, c squared is equal to a squared minus b squared. So we know what a is, we don't know what b is, we don't know what c is either. So right off the bat, this equation will be useless, but we are given this little bit of information, this relationship that a is equal to 2 times c. So with that, we can find what c is. So a we know is 4. Right, so 4 is equal to 2 times c. And dividing both sides by 2, we get 2 is equal to c. Okay, so coming back over here, c is equal to 2, so we have 2 squared is equal to a squared, or 4 squared, minus b squared. And we'll just go ahead and solve for b. So we get 2 squared is 4, 4 squared is 16, 4 minus 16, subtracting over, we get a negative 12 is equal to negative b squared. And dividing through by a negative, right, we have that b squared is equal to 12. And we'll just go ahead and solve for b. That implies, taking the square root of both sides, that b is equal to the square root of 12. Okay, now we have our a and our b, and like we said, we can put that into our standard form and see what we get. So, taking it on the top, x minus h, the x coordinate of our center, so x minus 1 squared, all over b squared, or the square root of 12 squared, plus y minus k, or y minus 4, quantity squared, all over a squared, or divided by 4 squared, and that's equal to 1. Now, this is a sufficient form to leave it in, but we can also simplify the denominators, and we'll go ahead and do that. So we can also write this as, in standard form, as the quantity, say, x minus 1 squared, all over square root of 12 squared is 12 plus y minus 4 squared over 4 squared is 16, and that's equal to 1. So in standard form, there we have the equation of our ellipse with our given characteristics. There we are. Thank you very much.